Hello students at home, this is Helizchem, and today, as I promised in my last video, I will talk on knowing gases that displace air. This is a continuation of the video I made on methods of gas collection, where I promised to bring you or to show you how to know gases that can displace air, for you to know the method that you will use to collect such a gas. I want you to recall that if a gas is denser than air, then the best method to use is downward delivery of water, otherwise known as upward displacement of air. That is, a gas which is denser than air will be collected by downward delivery of water, otherwise known as upward displacement of air. Upward displacement of air. On the other hand, if a gas is less dense than air, then the best method to use is upward delivery of water or downward displacement of air. This is just a recall from the last topic. This is just a recall from the last video I did on methods of gas collection. Now let's go to today's topic. How will you know that a gas is denser or a gas is less dense than air? Because we have some gases that are capable of displacing air while others are not capable. For you to know the gas that can displace air, we have to find the vapor density of such a gas, having in mind that the vapor density of air is taken to be 14.4. So when you have a gas which has a vapor density that is greater than 14.4, that means such a gas is denser than air. This is what I'm saying. A gas with vapor density which is greater than 14.4 is what? Denser than air. And because it is denser than air, you are going to use what? Downward delivery of water to collect such a gas. What am I saying? I said if you have a gas with vapor density which is greater than 14.4, that means such a gas is denser than air, and the best method to use is downward delivery of water. On the other hand, if you have a gas with vapor density less than 14.4, then such a gas is less dense than air. Such a gas is less dense than air, and the best method to use is upward delivery of water, otherwise known as downward displacement of air. Having known that, because that is the basis, if you want to know the gas that is denser or less dense, you have to calculate the vapor density of such a gas, and that will give you an hint to know the best method to be used to collect such a gas. But I want you to remember that the formula of vapor density of a gas is given as vapor density is equals to relative molecular mass over 2. Don't forget, this formula is taken from here. We know that relative molecular mass is equals to 2 times vapor density. So if you want to find the vapor density, you have to divide the relative molecular mass of that gas by 2. So this is the formula we are going to use to know the vapor density of a gas. In my last video, I said that CO2 will be collected by downward delivery of water because it is denser than air. Let us see how we come about that. The first thing is to find the relative molecular mass of CO2, which is carbon is 12, oxygen is 16, 2 times 16, and that will give us 12 plus 32. If you sum 12 plus 32, you will get 44. That is the relative molecular mass of CO2. Now, the vapor density of CO2 will now be relative molecular mass divided by 2, which give us 44 divided by 2. If you divide 44 by 2, you get 22, which is the vapor density of CO2. If you look at this value now, 22, which is the vapor density of CO2, is greater than 14.4, which is the vapor density of air. So having known that the vapor density of CO2 is greater than 14.4, that means CO2 is denser than air. And so the best method to collect CO2 is downward delivery of water, or upward displacement of air. Upward displacement of air. Hello viewers at home, I hope you got values from this topic I treated. If yes, I want you to go to the comment section and tell me how you arrive at the vapor density of ammonia for it to be collected by upward delivery. Because in my last video, I said ammonia will be collected by upward delivery or downward displacement of air. Now, go to the comment section, work it out, and show to me the vapor density you obtain for ammonia and why it is collected by upward delivery of water. Stay tuned on this same channel, Helizchem, for more interesting topics like this. Bye.